Hello, good people. Meet again with me, Mr. Gilperd, and today we are going to talk about the density. So we are going to talk about the density. Uh, Density. Okay, before we start, um, let us check your focus on this lesson. I have 1 kilogram of styrofoam. 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 And I have also 1 kilogram of metal plate. Metal plate. Okay, let's make it specific. Um, Steel plate. Okay, steel plate. Correct. 1 kilogram of styrofoam and one kilogram of steel plate. The question is, which one of those two uh, uh, things that has the highest mass? Which one is the highest mass? Which one has the highest mass? Of course, yes. None of them has the highest mass because both styrofoam and steel plate are 1 kilogram. 1 kilogram. So they're the same in a mass. And the second one, which one has the largest volume? Styrofoam or steel plate? If they have the same mass. Yup, styrofoam has the largest volume. So styrofoam has the largest volume. If 1 kilogram of steel plate only maybe 20 centimeter cubic, but 1 kilogram of styrofoam it can be uh, 1.5 meter cubic. Right. So that is about the uh, uh, comparison between two different material which has some mass and different volume. So in this density we need to focus on these two things. The first is mass and the second is volume. So the mass is amount sorry the mass is the number of the particle of the object. So if you have a solid particle here, number, so each particle has mass. Okay, so number of those of whole particles that fill in this object is counted as mass. Mass can be counted as gram or kilogram. Right. While the volume is the amount of space of the object that takes up. So space of the object. So if you see here, okay, I draw the bigger one. So this is the particles. Alright, the particle of solid because um, it has a fixed order. Okay, the space that I mean is this, right? So if they has more spaces, it means the volume of this um, object is larger than the particle that has a smaller space. So that is a volume. So the volume consists. The volume is the calculation of three dimension, three-dimensional object. So the large, the length, width, and height. So if you count it, if you count the measurement of this, and the unit is centimeter, so centimeter, centimeter, centimeter. So the length times width times height. So centimeter times centimeter times centimeter, it will be centimeter cubic. If you use a kilogram for a unit, sorry, if you use meter for the unit, so it will be meter cubic. Why we are focused on this mass and volume? Because if you talk about the density is the mass divided by volume. So the unit of this density is either uh, gram per centimeter cubic or kilogram per meter cubic. So if you want to use CGS, centigram and meter, centigram as second, or kilogram, meter, and second is okay. As long as the unit of uh, uh, the upper one and the bottom one are the same, right? You want to use gram per centimeter cubic is okay. Kilogram per centimeter cubic is okay. So density is a mass divided by volume. All right. So if you see from this formula, this volume is affected more to the density. What did I mean? All right. So we okay, we open the new open the new page here. All right. Again, the density is mass divided by volume. So this volume is affect more to the density. What do I mean? If we have, okay, we take the previous things. We have the styrofoam and steel. Okay, the mass of them, the mass of styrofoam and steel are the same. Okay, 1 kilogram, and it also 1 kilogram. You said before that the styrofoam has the larger volume than steel. Let me, okay, let me choose. Okay, okay, 1 meter. Okay, so styrofoam is 1 meter cubic. 1 kilogram of styrofoam has the volume of 1 meter cubic, while 1 kilogram of steel is only 0.2 meter cubic. Alright, so now this volume will affect the density. So which one is the denser? Which one is which one has the most density? Styrofoam or steel? Let's check. Density is mass over volume. Now styrofoam. The mass of styrofoam is 1 kilogram, and the volume is 1 kilogram. Sorry, the volume is 1 meter cubic. So 1 divided by 1 is 1 kilogram per meter cubic. So the density of styrofoam is 1 kilogram per meter cubic. And how about the steel? You know, steel. The steel is the mass of steel is 1 kilogram, and the volume of the steel is 0.2 meter cubic. It means the density of the steel is 5 kilogram per meter cubic. See, see that steel has the smaller volume than styrofoam, and it has higher density than the styrofoam. So volume is really affected to the density. The smaller the volumes, if the mass is the same, the smaller the volume, the more dense is the object. Okay, so that is to prove the volume is really affected to the density. And now, how to find the mass. So to find the mass of the solid, liquid, solid, liquid, and gas. To find the mass of solid, you just measure on the weight balance, on the balance. You just put on the weight balance, on the weighting balance, and for the liquid, you put the liquid on the container. Okay, but before you put the liquid on the container, okay, you put the container on the weighting balance, weighting balance. Okay, and then you record the mass of this container. Record, so mass 1, and then after that you put the water, the liquid, to the container, and then you put to the weighing balance. You have the mass 2. So the first is the weight of the weight of the container only, and the second is the weight of the container plus the liquid. So the mass of the liquid is mass 2 minus mass 1. So that is the mass of the liquid. That's easy. And now how to measure the volume of the gas. Same thing like what you do here, but don't forget to put the gas in a closed container, because the gas will escape if there is any cavity that connected to the environment. So same thing. The first is, okay, just use balloon. Okay, we use balloon to measure the mass of the gas. So first is you put the balloon onto the weighing balance. You have a mass 1, and then you blow the balloon and you tie it up and put on the weighing balance. You have the mass 2. So mass 1 is only the balloon, and mass 2 is the balloon and the gas inside it. So to find the mass of the gas is mass 2 minus mass 1, and you will have the mass of the gas. So that is how to count the mass. Problem solved. Now, how to find the volume? The volume of the gas of the liquid. Okay, this is one of the solid of the liquid and gas. Alright. So to find the volume of the solid is very easy if if it has a fixed shape, like uh, here the cube. So you just count the length times the width times the height. You will find the mass. But if it's irregular shape, okay, irregular shape like this, you need the Archimedes Eureka's way to find volume. So you take a graduating cylinder or the measuring cylinder that has scales here, and then you fill out with the water. Fill out with the water. Okay, fill out with the water, and then record the first volume, and then after record the first volume, okay, with the same graduating cylinder, okay, just pretend that this is the same. Okay, uh, after you record the first volume, you put this. Okay, so you dip the irregular shape thing into this measuring cylinder. So you put here, and what will happen next is the water level of this measuring cylinder will be go up, and then you record the volume. Okay, so the first volume is the liquid, the initial liquid without the object inside it, and then the second volume is the water level with the object inside it. So the volume of this irregular shape is second volume minus first volume. So you find the volume of irregular shape object. So that is to find the volume of the solid, and the second is the liquid. The volume of the liquid. If you want to know the volume of the liquid, is very hard, because you have to take the measuring cylinder, okay, and then you pour the liquid to it, and you see the scale. So that's volume. Very, very hard, right? It is. Okay, that's a jokes, man. That's a jokes. Okay, so now gas. To find the volume of the gas, please please aware to the temperature of the room. So if you want to measure the volume of the gas, please only do it in the same place, because the volume of the gas is very, very sensitive. The particle of the gas is very, very sensitive. If the temperature of the environment is high, you remember that the particle will move faster, so it will collide. The volume will be bigger. it expands. If the temperature is low, the movement of the gas will be slower, so it shrink. So just use one place to record the volume of the gas, right? So the volume of the gas, we usually use the tube that has a scale here. Okay, a scale here. You fill it, you blow it with the gas, and then you let this gas out, and you see the scale here. That is the um, volume of the gas. Or if you want to use balloon, but remember that you have to measure it in the same place. Do not move anywhere, because it will change um, the volume, right? So you just measure the circumstances of this balloon, so you find the volume of the gas. But it's not accurate, of course, because you also count the thickness of the balloon itself. But it's okay. All right. So now you know the volume of the liquid, the solid, and the gas, and also the mass. How to find the mass of the liquid of the gas. All right. And next is the density of water. If you have a glass here, a jar. Oh, this is not a good jar. You have a jar. It's also not a good jar. It's okay. And then if you put water, oil, and honey, right? You put water, oil, and honey. It will make 3 layers. So water, oil, and honey. Oil has the lower density than water. Water has lower density than honey. Oil has lower density than honey. Honey has higher density than oil. You know what I mean? So it means the honey is here. Honey placed at the bottom of the uh, jar. And then the second one is water. So the water is here. And the last is oil, because oil has the lowest density between them. So that's the density. So they will, even though you pour oil first, and then honey second, and then water the last, it will the layer placed like this. The oil will move up, and then the honey will move down. Then how about this? You have a water, and then you put a styrofoam here against styrofoam. What will happen to the styrofoam? Yes, it will float, because styrofoam has a lower density than the liquid, the water. In this case, is the water. But water also has the force called the buoyancy force. Buoyancy. So buoyancy is the upthrust, the force that push that push the things up, so it will goes up. The direction of the force is the opposite of the gravity. So the force, this styrofoam has a force, gravity force, while this water has the buoyancy force. In this case, the force is higher than the gravity. The buoyancy force is higher than density, or you may say that this is the positive buoyancy. If you put a coin here, which is smaller than the styrofoam, it will sink. It means the buoyancy force is negative and the gravity force is positive. So that is the buoyancy force and the gravity force. Sorry, the gravity force and density. All right, so that's all for the density, mass, volume, and the density. If there is any advice, if there is any command, and if you find a misconception, please tell me. Just let me know. And don't forget to not subscribe this YouTube channel. Sayonara.